Okay, before we start with this, we're gonna talk about parallel lines cut by a transversal. Why? Because we're gonna need these properties in a little bit. Okay, so let me try to draw parallel lines. Parallel lines are lines that will never consummate their love. You see, they're so close, they follow the same path, but they will never touch. Okay, so these are two parallel lines, and I know they parallel because I just traced them over the lines that I already had on this paper, right? Now let me trace a transversal. So this is a transversal. Okay, it's a line that cuts or intersects the two parallel lines. So what's so peculiar about this? Well, we need to talk about the relationships between the angles formed by the parallel lines. All right? If we can prove these relationships of with these angles, then we can say that the lines are parallel. For example, let's start with this. How many degrees in a straight line? Okay, in a straight angle, how many degrees do we have? Excellent. You see that? So we have 180 degrees. Okay, cool then. So this is a straight line, and between this angle and this angle, we have 180 degrees. It's like saying half a circle. Okay then. So when you have a straight line and it's divided into two angles like this, it's called a linear pair. A linear pair is always equal to 100, and the sum of the angles is equal to 180 degrees. Okay, cool then. So for example, if this is, let's say this is 100 degrees, then this guy right here is going to be 80. See that? And that's what we call a linear pair. Now guess what? This transversal is also a straight angle. See that? So that means that, and if I turn the paper around, that means that this angle and this angle are also supplementary. You know what the word supplementary means? It means that they add up to what? To 180, right? So then this angle plus this angle, so this angle should be how much? There you go, 100. And I wrote it the wrong way. No, let me go back over here. Oh gosh, let me rewrite it. So this is 100 degrees. Okay, you see that? And of course, again, this is a straight line. So if this is 100 degrees, how much do you think is this one? 80. Very good. Okay, so now to define a couple of things. You see this 80 and this 80? They're opposite to each other, right? Well, this is what we call vertical angles. You see this 100 opposite to this angle opposite to this other angle, and this 100 is equal to this 100. They are vertical angles. So what is our conclusion? That vertical angles are congruent. So vertical angles are congruent. Okay, cool then. Now let's talk about alternate interior angles. Let's talk about alternate interior angles. Alternate interior are nothing more than angles that are in the interior of the parallel lines. You see, this is the interior of the parallel line. This area right here is the interior. Okay, this is the interior. So alternate interior angles are nothing more than angles that are alternating. In other words, one will be up on the left and the other one will be down on the right. So notice something. This is an acute angle. It's 80. How much do you think this angle measures right here? It's also acute. Correct, 80. Oh, nice. Okay, let's take a look at this angle right here. This is an obtuse angle. This is 100 degrees. So let's take a look at what will be the alternate interior of this angle. That will be right here. See that? Okay, so then this will also measure 100 degrees. So our conclusion is that alternate interior angles are congruent. Ah, beautiful. Okay, what else do I need to know? Well, consecutive angles are angles that are on the same side of the transversal. Okay, like this. Okay, this is the transversal right here. Transversal. the line right here. So this part right here, look at this angle. Consecutive angles, or same side interior, because they are on the interior, right? Same side interior angles. They add up to, oh, they supplementary 180. That's 180. Beautiful, 180 degrees. So now we know about it. Let's go on to the other side and let's see if it's true. Same side interior angles. Yep, 180 is 180. Oh, beautiful. Anyways, now let's talk about alternate exterior angles. So let's talk about alternate exterior angles. Okay? So let's see. Exterior means not in the interior, guys. So it means out here and out here. So alternate exterior. Let's take one of the exterior angles. Let's take this 100. So this 100 is right here on the upper left. So that means that the alternate exterior should be at the bottom right. So this is right here. This angle is an obtuse angle. Therefore, hey, look, this is also an obtuse angle. So this measure should be 100. Beker, hello. Like, you already had 100 here. You could just use the definition of vertical angles and say that these and these are congruent. Oh man, that's true. So that means I don't need this 80. I could just go down here and say, okay, if this is 80, then since vertical angles are congruent, this is 80. All right. All right, cool then. Now let's draw another pair of parallel lines, because I really need you to understand something, because we're gonna be using it. And let's go back over here as well. Look at what happens here. I have this. Let's say I go and I come over here and I just draw another what do you call that? Another transversal. Look at this. Let's say these are parallel lines as well. Let's call the transversal parallel lines. So if they are parallel lines, then I want you to think of what the shape is. This is what we call a parallelogram. Okay? Now, parallel lines cut by a transversal. Parallel lines cut by a transversal. Oh, it works both ways. Yes. So what do I need to know? Well, if we look at this diagram like this, then we're gonna say that these two lines are parallel and that this is the only transversal. So what did we know about consecutive angles on the same side of the transversal? That they were supplementary. No way, Bex. Yes. And with that, you already know what's going on. If this is 100, you know how much is this. This is the obtuse angle, so this is the acute angle, so supplementary. And if this is 80, you know how much is this. Linear pair. If this is 80, you know what this is. 80 because they're vertical angles. Yo, not only that, since this is a parallelogram, because it's a parallelogram because all the sides, look, opposite sides are parallel. Then look at what happens to opposite angles. Ah, beautiful. So opposite angles in any parallelogram are congruent. Look, opposite angles, they're congruent. All right. So basically that's all I need you to know right now. And just one last thing. The transversal can take any direction. So let's say these are my parallel lines cut by a transversal. Okay. And since I am OD nice, I want to also turn this into a parallelogram. Just to show something, okay? All right. So look, this angle right here should be equal to this angle right here. See that? Look. Don't forget what I'm drawing right now. So this is supposed to be a parallelogram. Just remember, this angle right here is congruent to this angle right here. Okay? This angle right here is congruent to this angle right here. And that's all I gotta say. Now let us move on to the lesson. Well, first you're gonna try it on. So, ways to prove triangles congruent. We have side, side, side. We have side, angle, side. We have angle, side, angle. We have angle, angle, side. And we have hypotenuse and leg. All right? So, this we've seen before. Now, what are the ways that we cannot prove triangles congruent? By or angle, 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 or angle, side, side, okay? It's called the donkey theorem. All right. Now, I will explain to you why not angle, angle, angle. Why it cannot be used. After you've proven your triangle's congruent, there's only one thing to do. Like let's say I prove all my triangles congruent. For example, the theorem, okay, they're telling me that AD is congruent to AB. Okay, AD congruent to AB. Then that angle 1 is congruent to angle 2. Okay, perfect. Now they want me to prove that CD is congruent to CB. That CD is congruent to CB. How in the world am I going to prove that? Oh my God. First, the rule says that I have to prove the triangles congruent in every aspect. If you can prove the two triangles congruent by one of the methods, then it's over. Every other part of one triangle will be congruent to every other corresponding part. So let's see now. AB is congruent to AD. Now these two angles are congruent, so I got angle, I got side, angle, I got side, angle. I need one more piece of information, but I need facts. What can I do? Right, AC is a side of this triangle, but it's also a side of this other triangle, so it's congruent to itself. Oh, shoot. So now that's it. That's it, look. Side, angle, side. Side, angle, side. Oh, I have proven the triangle's congruent. So then let us justify our statements, okay? So this piece of information, what would be the reason here? Yes, given. So, beautiful. Now, why did I say that AC was congruent to itself? What property allows me to do that? Oh my God, you are on point there, definitely. The reflexive property. Okay. Now, I said that side, angle, side, and side, angle, side. So I did prove them congruent by beautiful. So this is what I was talking about. Once you have proven triangles congruent, and that's not what they're asking you. If they're asking you to go beyond that, then your next justification will be sibigitak. Look. Sibigitak. Sibigitak. Or CPC tac. It doesn't matter. It's easier to remember this than to remember this. Sibigitak means corresponding parts of congruent triangles are congruent. So that will always be your next justification when you prove triangles congruent. As simple as that. See, corresponding parts of congruent triangles are congruent. Okay then, so I guess we get to start, rumbling here. So it says, in the diagram of triangle ABC and triangle DEF below, AB is congruent to DE. Okay, AB congruent to DE. And angle A is congruent to angle D. Okay, good. Question, which method can be used to prove that the triangle ABC is congruent to the triangle DEF? And this is where you have to use your little noodles and come up with a response. Right. Angle, side, angle. Okay. The diagonal AC is drawn in parallelogram ABCD. Which method cannot be used to prove that triangle ABC is congruent to triangle CDA? I'm not gonna say it, you say it. Oh, all right. You gangster, definitely. Okay. So now here. Okay, first you need to attempt this and then we could do it together. All right, you attempted it and now let's do it together. So what do I know? It says, which method can be used to prove that triangle ABC is congruent to triangle CDA? CDA, so this triangle and this triangle. Well, let's see, what do I know? Well, I know that AB is parallel to CD. And I also know that angle ABC is congruent to angle CDA. Wait, opposite angles are congruent. And this is parallel to this. Yo, this is a parallelogram. Okay. Anyways, let's not jump to conclusions. In order for you to prove, okay, that the triangle is congruent to the other triangle, even though you could say it's a parallelogram, you still haven't proved them congruent, you need another piece of information. Okay, so what do I know? I know that AC is congruent to itself by the reflexive property. Why? Because it's the same side for both triangles. Okay, so I have an angle and I have a side. What else do I need? Well, remember when I gave you the preview? This is what I meant. Remember, if two lines are parallel, you can you are always allowed to extend these lines. What for? Oh, people, look. Look at the diagram here. Let me help you with the drawing of the diagram here. Look, parallel lines cut by a transversal. Parallel lines cut by a transversal. Look at alternate interior angles. Wait, you're saying that this angle is congruent to this angle? Duh. Oh my God. You got it. Angle, angle, side. Angle, angle, side. Angle, angle, side, angle, angle, side, angle, angle, side. Okay. So that's how it works. Sorry. Let's see now. No, that's it for your page. Now, for 29B. For 29B, it says, it would have been nice if I erased the answer, right? Sure. Okay. Now I did, so ha 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 ha. For 29B, it says, to prove that these two triangles are congruent, okay, sorry, what other piece of information is needed? I need to prove them congruent by side, angle, side. Well, based on the information given to me, I know that this side is congruent to this one, and I know that these two angles are congruent to each other. So therefore, I got angle, side, or I got side, angle. Well, congruent by side, angle, side. Okay, definitely I don't have information on these angles. So I'm gonna go by this. Side, angle, so I need side, angle, side. Side, angle, side. Oh, side, angle, side. I wouldn't be able to choose this one because it wouldn't be side, angle, side. It would be side, angle, and I don't know how to call this. Or it would be, no, on the contrary. If I put this one right here, it would be side, side, angle. Whoa, you cannot do that. Remember? Angle, side, side. The word that it spells. So then I need AG to be congruent to OL. Oh. choice number 2. All right. What about this one right here? Well, it says, in the diagram of trapezoid ABCD below, diagonals AC and BD intersect at E. Triangle ABC is congruent to triangle DCB. So these two triangles are congruent. All right. Which information is true based on the given information? All right, let's go over this. AC is congruent to BC. AC is congruent to BC. Right away, this line is longer than this one. We're talking about the same triangle. So AC, so that's not true. Okay, let's try the next one. Angle CDE is congruent to angle BAD. CDE, okay? Angle CDE, CDE, this angle right here is congruent to angle BAD, this angle right here. Well, you tell me. Okay, I'm gonna put this on hold right now. I'm gonna believe that this is the right answer. Let me go on to this choice. CD is congruent to AD. CD is congruent to AD. Does that look logical to you? Right. And then angle CDB, angle, let me put in a different color, angle CDB, CDB, this angle right here, is congruent to angle BAC, BAC, what, CDB, CDB is congruent to, oh, okay, I'll get back to this one. It's congruent to BAC, BAC, to this angle right here. Okay, it's possible. But then where did I go wrong with this? How did I get confused? Let's see again. Angle CDE, CDE, that's this angle right here, okay? Congruent to angle BAD, BA. Oh, I was talking about this angle. Nah, that's not possible. This angle cannot be congruent to this angle. See how we fix our mistakes? Beautiful. Okay then. Now let us move on to the next problem. Okay. As shown in the diagram below, AC bisects angle BAD. Okay. BAD, so and angle B is congruent to angle D. So which method could be used to prove that the two triangles are congruent? Hello, you know that AC is the same side for this triangle than for this triangle, so it's congruent to itself. So I could use angle, angle, side. Oh, okay, angle, angle, side. Yeah, angle, angle, side. So it will be angle, angle, side. Beautiful. Okay, now using this information, it could be proven that, well, let's see, in the diagram below of ABCD, all right, AC is congruent to BD, so this and this are congruent. All right, so what can I prove with this information? Well, look, BC is right here, all right, the segment BC. So I really don't know how to approach this, so I'm going to give it values. Okay, they saying that AC is congruent to DB, so I'm gonna make AC to be 7. AC will be 7, and DB has to be 7 as well, right? I mean, let's put the 7 right here. Okay then. But look, we have 3 parts right here. Now, let's make AB the number 4. Let's make BC the number 3, so I could have 7. Okay. Now, if BC is 3, CD or DC has to be 4, because the whole DB has to be 7. Okay. So what can I conclude? I can always conclude that AB is congruent, look for, to CD or DC. So I conclude that AB is congruent to CD. AB congruent to CD. Okay. Okay. This is gonna be fun. Alright, so much fun that I have to erase this. Okie dokie. So what do I know? They're telling me that AB is congruent to CD. They're telling me that AB is congruent to CD right here. Okay, this is the reverse of the other problem. So which statement could always be proven? Well, I got three parts right here. Now, BC has a fixed measure. If I add BC to this and I add BC to that, I'm still gonna add the same amount to both pieces, right? And since both pieces are the same size, then nothing will change, right? Cool then. So let's see now. This is gonna be 4 and this is gonna be 4. We know that they're congruent. Let me give a value for BC. So if I add BC to here, I'm gonna get AC being 7. If I add BC to this, I'm gonna get BD to be 7. So my conclusion is that AC is congruent to DB. Oh, that wasn't that bad. Wow, that was easy. Alright, so now the proofs, these proofs we're going to have to do in class, okay? Because it's kind of like difficult and it's a lot of writing. So I'll see you on the next lesson.